and put in a marker. So today what we're going to do is we're going to go through the event queue pattern that we did, that we read through yesterday. We implemented the code examples in JavaScript, but now I want to try implementing these examples in Rust. There's no inheritance in the example, so it should be pretty straightforward for us to do. I don't think I'm going to get to doing channels today, especially since I need to look into how those work, and that might take a little bit more time than just implementing normal Rust for that. But that is actually something I have on my list to look into, and maybe that would be a good sort of exploratory stream, sort of look through the documentation for channels and try to implement them. But I have created a new, let's see, here we go. I've created ourselves a Rust project so we could run this and it get going. So let's do cargo run. If you are live, I'm going to turn on the highlighter. You can do bang line in chat and that will highlight a line. You could also add a message to that or a question, or just use that to highlight any mistakes I make, or if you want me to describe some line a little bit more often. All right, so let's go ahead and get going. We're gonna come down here and see what our first example is. Right, okay, so we're starting with an audio class. And the first thing we're doing is handing it all around. So we're gonna have a struct audio. And it doesn't look like we have anything in it. In fact, it looks more like this is just a struct for us to import on audio. And then we can have a public function play sound that takes in an ID. So now they're having a sound ID is the ID, which sounds like it could be a number. That also sounds suspiciously like an enum there, because if we have an enum sound, then in here we can have swoop could be one of the sounds. So we could have an ID, which is type sound. And we're also going to have a volume, which is going to be an I32. I assume it's an I32. It might be an F32 between 0 and 1. In fact, I think when we do GGEZ, everything really is I32, F32s. Okay, so then we see how they're going to implement it. We're going to have some kind of load sound function that just exists out here. So let's go ahead and we have main. Let's add that down here. So main load sound. Now this is going to take an ID, which is type sound. And it's going to return a resource. So some kind of resource, we don't know what that is. We could right now just sort of pretend and just make this a string. And just we're pretending that it's a resource. Okay, so we do that. We could in fact match, return match off of ID. And this is going to be sound swoop. If we're passed in swoop, then we want string. In fact, yeah, let's just do this. String from, and then this can be swoop sounds. Okay. Now we can use this. So I'm doing this because I want this to be compilable. I want us to be able to compile it. I want us to get help from the IDE on this. And a lot of that is because in Rust, if the IDE says that it's going to pass, and there's no problems, no red, it often does compile, and then if it compiles, it often works. Okay, so we're gonna find the resource in here first. So we know this is a string, but we don't have to say what that is because of auto, sort of like, what is it? Auto discovery of what type of return value type, whatever. I need to drink my tea, not just have it in front of me. Okay, so let resource equals load sound, and we're gonna pass in that ID. Then we're gonna have the channel, find open channel. Okay, so we'll have another function here. Find open channel. This is gonna, it sounds like maybe we'll just, this will be just like an int, an I32. And let's just return 55. It's a random number, I guarantee it. Actually, no, if I remember correctly, channels were like 0, 1, 2, 3, or 4, or something like that. It never went that high in like those old Sound Blaster channels. Okay, so then we have to check to see if the channel is -1. So what this is saying is it couldn't find the channel. Well, in Rust, we have a really easy way to deal with that. What if I do an option here? So we're gonna do an option. So it's gonna be something or nothing. If it's something, we're gonna get an I32. And so we're gonna return as sum 4. Now in play sound, we're gonna have to grab that channel. So we need to get here. Okay, so in let channel equals just find open channel. Find open channel, just like that. Now that gives us an option. So we need to like unwrap the option. So I could just do a dot unwrap. I could also do a like question mark operator. If I do a question mark operator, we're gonna need to handle, no, I guess it does have to be, we have to do an if let, sorry. Got it wrong. We're gonna do this. Let channel equals if let sum, and this is gonna be the channel. I know that's maybe a little bit hard to read. We could just do like, I mean, inner channel. That way it's easy to see like how the scopes are separate and like separate from each other, because I could just do the exact same variable and it would still work the same because they're in sort of different scopes. So if let sum inner channel equals, and then the thing we're doing, which is going to be calling find open channel. So the result of this, now we have inner channel, and we can just return inner channel into channel. All right, what are you upset about? Oh, and semicolon. If expressions without else, if value, oh right, we need an else. Like what happens if we have a problem? So if we have a problem, we're gonna want to just do nothing at all, right? We want to just an early return. So else return, but if I'm returning, I have to like tell it what we're returning. Oh, apparently not. I could just do a return like this and it, oh, look at that. It's bang. So this is something I learned yesterday, is that there is the bang return type, which I don't think you can actually call, oh, you can call directly. So return, just by itself, without handing anything into it, is the bang type, which is never. Like it's not even nothing. It's not null. It's not, none. It's just never. It never happens. So return with no values is never, essentially. And then at the end here, so it doesn't like that, because I don't think you're allowed to actually directly call bang. It's just something that it's using internally when it's saying, oh, hey, I'm not returning anything, but I need to return early, so that way I stop the code. All right, so now I have channel and resource. And I have to do this here because Rust won't, like, Rust is saying, well, what if it's null? What if it's none? You must cover that case. All right, and then finally we're gonna have this start sound function we're gonna create. So function start sound. We're gonna take in a resource, which we know that the resource is coming from this load sound. So we're just gonna say it's this string. We know that it's a channel. We need a channel, which we know is an I32. And we know we need a volume, which is an F32. And we're not going to return anything. It's just going to play the sounds. So what I can do here is I can just do a print line. And we're going to say playing sound doot on channel doot with volume. And then we'll just use all of these. So we have resource, which is what the sound is going to be. We have the channel, and we have the volume. And there we go. So here's our start sound and what that's going to end up looking like. So now let's call it. So down here at the bottom, we're going to start sound, pass it in the resource, the channel, and the volume. And that's it. And okay, we check that in, create a few sound files, start sprinkling play sound calls throughout our code base, like some magical audio fairy. I love that line. Okay, so let's say we have like something happening in here. So we're going to, where's our main? Here it is, our main. So let's just right away, you run this. So this is gonna be audio play sound, which I believe we want you to be like that. Play sound, we're gonna pass it in the idea of the sound. So that's gonna be sound swoop. And the volume, let's just do 1.0 to be max volume. It's actually suggesting that we use some kind of const for this, which we can totally do that. So we can do const max volume equals 1.0. Now we can't actually do a constant without also telling it what type it is. It won't be able to infer this. And so then volume is max volume. Okay, and then play sound, semicolon that, because we're not returning anything from this. Save. We got no errors, no warnings, and I should be able to cargo run. Playing sound, soup sounds on channel 4 with volume 1. Okay, so that's sort of like the beginning of where we are. Now, this gets into a problem because now we've spread this all throughout the code, and it's just sort of happening right away. And if something wants to play like 300 sounds, the entire game halts while it loads up all those sounds and then plays them. Okay, so we're gonna have a play message. So we're gonna create the play message struct and use this to sort of insert into an array of all of our sounds. In JavaScript, this didn't make much sense for us because of weak typing. We don't need something like that. However, in here, this might be a little bit more apt for us. So let's do this above audio. We'll do struct play message. We're gonna have an ID, which is a sound, and we're gonna have a volume, which is an F32. Next, we need to give audio some storage space to keep track of these pending play messages. Now, your algorithms professor might tell you to use some exciting data structure. Right. But we're going to use a simple array. So in audio, and we may need to like change this a little bit because I believe he wants us to have this be a sort of like set it all up with like some kind of default values. The problem that we have with that is we can't really do default values. We don't want them to like to actually play. So we'd probably want to do them with like options. Let's go and start going down here first and figure out what we want to do. So class audio, public static. Okay, so when we init, so in here we want, essentially this is really the index. But if I follow there, we're doing num pending, and this is going to be I can't remember what type the index for this is going to be. I don't remember if it's like an, I don't think it's an I32. I think it might be a usize, but I might be wrong. It might not. They might. Since some updates ago, we might not use usizes very often anymore. All right, and then we have max pending. So max pending, and this is going to be. So we're going to say we can hold 16 sounds at the same time. It's going to be an I32. Now we want this to automatically be set in some kind of initial function. So we're going to want to implement. We already are implementing audio. We want a new function now. So pub function new. Because I don't think there's such a thing as like a const inside of a struct, or at least I've not looked for one and found one. Because are we still doing this in, I think we're still doing this as, well, it's a singleton, so we can still create a new one, and then we'll have to like do play sound off of that. So I think that'll be fine. When we create a new audio, we're gonna have to store these things in. So the number pending, maybe we don't even take anything in. Maybe we just sort of set it up and these are the defaults. So we're going to return an audio and we're going to say return audio num pending is 0 and max pending is 16. All right, so that gives us these two. Now we have this play message. No, pending of max pending gives us a play message. Okay, I don't know why that's like on. Oh, it's static. It's like a computed. I think that we would have to create that as a function here. So like an internal function of like get current message. We're gonna do self, and we're going to return a play message. And so then, now we don't have, oh, that's what they're showing. Pending. Okay, never mind. We don't have this. I misread the C++. We're going to have a pending here. Pending is going to be an array. So just a simple array, and we're going to have play message as the type, and then the number of them is going to be this max pending. Now, unfortunately, we have to set this. Hold on, it's up here. Pending is an array of play message. And then we have to say how much, like how big this is here at this point. So maybe this should be another constant. So const max audio pending. I32, I'm not sure what it needs to be, and we'll just say that you're 16, and we'll put in max audio pending. Okay, we did expect this to be a U size, so you are a U size. All right, so that makes you happy, and so then pending is just going to be, can I say an empty array? No, I have to like actually build it out. Expect an array with fixed size of 16 elements, found one with 0 elements. And I can't remember off the top of my head how to like easily create an array with that many elements without like doing a loop. So if I want to do let pending equals, can I for loop and return off of that? I don't think I can. Is there like a Rust lang? Let's go look at the documentation. I want a simple array, primitive type. So these are trait implementations. Let's see. Mute array of type this equals 0, 3. Okay, this creates 0 with 3 of them. Okay, that's what I wanted to see. So I don't need to use this. It's going to be play message like that. Now the problem is I need to set like what the sound and ID is. I think this would be best to like have a new so I can initialize it really easily. So implement on play message, pub function new. We're going to return a new play message and play message. But if we don't know what the sound is, this is going to have to be an option. So we're going to have to do an option that holds a sound. And this is going to have to be an option that holds an I32. And then this way, this could be a none, and volume could be a none. And so that makes that happy. So now here, I can say, okay, max play message, colon, new, and then semicolon, max audio pending. So the number of these that I want to create. What are you upset about? The trait bound play message, remember, copy is not satisfied. Right, because it wants to copy these over and over and over again. So I'm okay with that. So let's go ahead and implement copy on here. Copy on here. So copy and clone. Type two values can, wait, what's our real error? The trait copy may not be implemented for this type. This field does not implement copy. because sound doesn't implement copy. Okay, so derive copy. Oh. All right, so now that makes that happy. So we're cloning all the way down. We're getting our pending array here, which is set up with a bunch of play messages. And we don't need this max pending because we now know exactly how many there are here. So you're gone here. All right, no errors. Bunch of warnings, but that's a different problem. That was just so we can create this pending array, and then we have num pending, which is the index essentially. When we hit play sound, we're going to take in the sound ID, the ID, and the volume. What we're going to want to do is we want to assert that the num pending is less than this. Otherwise, we're going to turn some kind of error. So we probably now want an error enum. Maybe something like a custom error. And our first error is going to be, this is going to be the play audio. It's not really stack, it's a queue overflow. So if we come here under play sound, the first thing we need to check is if, which means this also needs to be a self. And this needs to be mutable because we're going to be incrementing num pending at the end. Whoa, clicked on that box, didn't want to do that. All right, so if self dot num pending. So as long as we're below num pending, we're fine. So actually we want to say if we're greater than max pending, so max audio pending, if this is the case, we want to do an early return of an option, which we want to return out a result. Now, I don't really care what this result is, so I'm just going to do empty parentheses, but the error we do care about. So that's going to be our custom error. And so I'm going to return, this is the error, and then our custom error, audio queue overflow, and semicolon that. Now over here, else return, we can now at this point in time return an OK, like that. And at the very end here, we need to return an OK, like that. And that should make the result that we're returning happy. Now this is saying, okay, so num pending is an i32, and this has to be a usize. So now we need to change num pending, u must be a usize. Or we need to do like some kind of conversion, but usize will be easier. What else do we need to do in here? So we've asserted this, and we return an error if we're overflowing. We need, if we get past this part, we need to do our pending, num pending.id. So we need to set this in the array that we're at. So all this stuff is happening somewhere else. So I'm going to go ahead and comment this out because we're not doing it here. In fact, none of this is happening here. In fact, even the start sound isn't happening here. What we're doing is after our assertion, as it were, we're setting inside of our pending. So self.pending of position self.num pending dot ID is equal to the ID that we passed in. But of course, it's an option, so this needs to be a sum ID. Not that big of a deal, okay? And then the volume. So self.pending, self.numpending dot volume equals sum volume. Now, what are you? We have expected I32. Right, you need to be an F32. All right, so we're happy here in this specific part of the code. And then increment numpending. So self.numpending plus equals to 1. All right, so now play sound will always return instantaneously or it will error out. And we can see that down here when we call it. It won't do that play anymore. What this also means that we can't just directly call play sound on this. We're going to have to, might as well not do you anymore. We're gonna have to like create an instance of the audio first. So maybe like the audio equals audio new. So this gives us the new audio. Yep, it just returns that. And now we can register a new sound with this. So audio dot play sound. We're going to hand it this sound swoop and the volume, which is max volume. Now, play sound returns a result with an error. So we have to handle this result because if I just do semicolon, it's going to give me a warning here. Oh, also you need to be mutable. Yeah, it's going to give me a warning here saying, hey, you have to handle this potential error that's coming in. So let's just do an unwrap here. Unwrap will crash the system if we do get the error. What are you? No method, unwrap. Oh, debug needs to, okay, so maybe not unwrap. What's the other ones? We have unwrap, expect. And then our message, error, plain sound. Oh, we can only do this if debug. Oh, if debug exists on it. Interesting. I didn't realize that we need debug on it. All right, let's go back to unwrap at the top here. Now, the other thing we can do, and maybe slightly better, maybe instead of doing unwrap, we match on this. So we're going to match on audio, audio.play sound, and we're going to get an OK. So if OK happens, we don't really care what's passed in. So it's basically going to be nothing. I think we can just do that. And we could just do a print line. I mean, we don't really care about this, do we? All we care about is the error case. So error, which means if we only care about the error, then we can do an if let instead. Okay, now I want to do an if let. If let, it's going to be custom error, and audio queue overflow equals this play sound. While we only have this like audio error, this works. I may need to refactor this if we have different types of audio errors that we want to handle all of them. Equals the audio.play sound. And then if this happens, we want to probably like panic. Panic. Let's see. Airplane sound. expected enum result found. Oh, it's a result. So I think it's not sum, it's error. Like that. It's error that holds this. That's specifically what we're looking at. Okay. We have our error code here. Now if we run this, it should be pretty boring because it just runs. We don't actually play the sound anymore. We just put it into our queue to play the sound later. How are we going to play the sound? We're going to have to now have an update method on here. So we have our pub play sound, pub function update. Update, it doesn't take anything in, so we're just going to be mute self, mutable because we need to like reset num pending potentially here. I don't think we need anything else, and we may not have to return anything, so let's find out if we do. And then all this stuff is going to happen inside of here. So let's make sure that it's all ready to go. So let resource equals load sound ID. Well, what we're doing here is we're going to loop through all of these num pendings. So let's go ahead and we could do the for loop. I think that would work. So for index in, so it's going to be 0 ... self ... num pending. Then we're going to go ahead and load the sound. Now we need the ID, so we need to grab that off of the pending here. So it's going to be, and this is going to be interesting because it's in an option. So we need to extract that out. So it might be better to extract that out up here. So we can do an if let. That might be good, because if we don't have the ID and we don't have the sound, then we want to exit early. Probably panic, but we probably want to return an error and let some, like the top level panic. So let's do another error here. And this is where we're gonna have to refactor maybe, like sooner than later. So let's do an error. Custom error, which is audio sound not found. Okay, so this is the result. We don't care about the left, but we do care about the custom error is passed in. Now it's just complaining that we're not actually returning this error. All right, so we want first to get this. So let ID equals if let sum ID. So this one I'll do like the idea with this, and we'll just show how the return handles that. The ID equals, and then it's going to be reaching into self.pending of position index. So if we find the sum ID off of this, we just want to return the ID directly into here. Let's see. Expected enum result found nothing. I'm returning to here. Let's see. Then we have an else. We're going to return. We're going to return this custom error. So it's going to be an error custom error, audio sound file not found, and then semicolon this. At the very end, let's go ahead and not in the for loop, but down here, return okay. Just to make that happy and make us get those errors a little bit less often. Okay, so let's, what are you upset about? Expected, dot ID. So that will give us the ID. So either we have the ID or we've exited out. So let's now do let volume, and it's gonna be the exact same thing. So equals if let some volume equals self dot pending position index dot volume. Then we're gonna return the volume, else we're going to return a custom error. Audio sound not found. All right, so now we have this volume, we have our volume, and we have our ID. Now we can start doing this. So load sound takes in the ID. So we're gonna pass in the ID. The channel, so find open channel, we grab that, and then we start the sound and pass all these in, and then okay happens. So that's fine, this is great. And then, num pending at the end of it. Right, so at the end of this, after we've done our for loop, before we return, we want to reset num pending. So that way we're like back at the beginning of the loop, because we just went through all of the possible sounds we want to play, and then we're good to go. So this is gonna be self dot num pending equals 0. So reset num pending. So how to use this? Down here in main, we create the audio, we play sound. So this is our swoop sound, and then we run update. So audio dot update, just like that. We have to handle the error that comes in here, which is gonna be a completely different error. So this is still fine. So if let error, our custom error, this is going to be audio not found equals audio.update, and we're going to panic. This is going to be the sound not found. This should never happen, but it's always possible that one of those like deeper level things had an error. And that should then play our sound in the command line here. So let's try it. Yep, playing sound swoop sounds on channel 4 with volume 1. If I come in and we do this twice. Now, when we play the sound, we're not gonna have to do this if let. Deeper in the library, I'm gonna use the question mark operator, and that will like push the errors up, bubble them up. In main, we can't do that because we don't return an error. Although I think you can sort of like set main to return an error. You can try that. And so here we play the swoop sound twice. All right. Of course, there's still better things to go, because what if we run out, like we're just gonna be able to do 16 songs? You can return an error or result action. Yeah, I do remember. Let's try that really quickly. Also, good morning, physics. I remember that not too long ago, we made it so we can return a result. So this and a custom error. Is that just yelling at me because I don't Custom error doesn't implement debug. Okay, so I need to implement on custom error, implement debug. So derive debug. Now what? Now it's expecting me to do it, and I haven't actually done it correctly. So let's down here. If we reach down here, we return okay. And custom error. So what I can do now here, I don't have to do this like entire handle and panic. I can now just do an audio play sound, skip all this stuff, question mark, semicolon. And then that just works. And then here we're gonna do the exact same thing. Now this does clean up the code quite a bit. I've heard a lot of different feelings about this. Question mark, semicolon. All right. Specifically in main, it's probably better to actually truly handle the errors yourself in main, but we're pretending that we're in some kind of library. And in the library, we'd want to use the question mark operator here. I know, it's so much cleaner when we do this. Perfect. Thank you, Physics. All right, so next up, a ring buffer. So we want to basically loop through that array over and over and over again. So that way we never really run out, except if we like catch up, if our head and tail catches up. So in audio, here it is. We're gonna have head and tail. So instead of num pending, we're now gonna have a head. I should change it up here first. So you're gonna be a head of usize and tail of usize. And so when I create this, head is 0, tail is 0. Pending is still gonna be exactly the same. We're gonna be like looping through this using head and tail. In play sound, we're now going to just use the tail to implement in. So as long as tail isn't outside of num pending, so this is gonna be self.tail, then we can go ahead and return this error. Pending tail, okay, so then down here, we have to add in, so self.tail for what ID this is, and this is going to be tail. And then tail is what gets incremented here. All right, so then we go into update. In update, if there are no pending requests, we don't want to do anything at all. So we're going to start with if self.head, if that is equal to self.tail, then just return okay, like that. So an early return, we're done. However, if we get past this, there is some sounds for us to play. So resource ID equals load sound. Okay, so then we're going to load the sound. Where is that? So we're no longer going to do this loop like this. So this for loop can go away. We're going to load the sound. Go ahead and save so that it's a little bit easier to see. So let some ID sound. This is self-pending. So we have to get get this stuff out of here. This is going to be the head. It's going to be self.head. Self.head. Then once we have that information, we can resource load sound, pass it in the ID. Channel, get the channel. Start the sound, pass it in resource, channel, and volume. That all is fine. And then this is going to be the head gets incremented. Bare Knuckle Waffle, good morning. Hello. And then, of course, we have our OK that we're turning at the very bottom. Now, we have a problem. As we can only now play 16 sounds ever in our game. Because as soon as that happens, the tail hits the end of that array and just sort of, well, we're actually going to get an overflow. Because we're going to try to get to the next index of the array that we promised was going to be only 16 long, and it's going to say, well, too bad, so sad, crash time. So instead, what we want to do is a little bit of this crazy math, which we proved last time. If you take a modulus of whatever of like the size that you're in, it's going to give you the index that you're in. Or at least, yeah, it's going to give you the, so if we give like 7 modulus 16, we get 7. But if we get like 17 modulus 16, we get 0. So we go like, this allows us to loop back around. So in play sound here, we assert, so it's going to be self.tail. And this is going to be a little bit interesting. So we're going to do a little bit different, and we're never going to have an audio overflow anymore. Or at least this shouldn't. No, we still can have an audio overflow because we can catch up. Even in a ring, we can still fill up 16 sounds. So we are going to have an audio overflow. Assert, so like tail plus 1. So let's see. We want to say that this is going to be self.tail plus 1 modulo, and this is going to be our max audio pending. If this equals self.head, so if we've caught up to the head, then we have a problem. This won't hit us right away because we're checking that plus 1, even though they're starting at the same indexes. We can't play the sound before adding the sound in. All right, so if that happens, then we return this. We have the audio cue overflow. Otherwise, self.pending, self.tail.id. So we do all this normal stuff, and then this plus 1 is actually now going to be equals to, and here's where we do the exact same thing that we have here. This is calculating what the index should be, what our next index should be. And then we return OK. So we're fine there. Now, an update, we're going to make a little update here too. So we don't have to check like the tail or anything else. We're fine here. We just play the next audio. So we're going to resource, load sound, pending head ID. All of this stuff happens. We're going to do the same thing here. So it's going to be equals self.head plus 1. Modulus the max audio pending, which gives us the ID of the array and sets it to that. And then I think that's good to go. So we have no errors. let's come into audio here. If we run update once, we should play one sound. So we loaded in 2 sounds. But we played a swoop sound. So just one of them. Now if I run update again, it plays both the sounds. So this way I could basically say, you know what? We're gonna only play one sound per frame. And that way we'll never get overloaded. We'll never play the same sound multiple times. Okay, so that's a good sign. What's next here? Now that we've got a queue in place, we can move on to other problems. The first is that multiple requests to play the same sound end up too loud. So if we have multiple sounds, we want to walk through and play sound here. We want to walk through all of the sounds that we're possibly going to play. And then we're going to set the volume to be whatever is the higher of the 2 volumes. So that's going to be fun. So here in play sound, we're first going to do this this for loop. I think we still need to do this custom. Do we need to do the custom overflow? No, I don't think we do. Because if we have all these different sounds to play, one of them might be the ones that we're already doing. So we need to do our for loop before this. Then we can check to see if we really need to like enqueue, we can do that test. So we're going to for loop through. So we're going to have a index in, and this is where it's going to get a little bit interesting. And I wonder if I'm going to have to create like a custom iterator for this. Index is not equals tail. Is there like a custom for loop? I think we might have to do like a while loop. Is there, we do while. Is there a do while? There's while and there's loop. But I don't remember any like do whiles or anything else like that. So I'm gonna have to do let index. If you all know a better loop for me to use, let me know. I'm gonna say index equals 0. It's gonna figure out what type this is really quickly. So well, index, oh, you need to be mutable. Okay, so while index is not equal, so not equal to self dot, oh, we need to set this not to 0, but to self dot head. And so while you're not equal to self dot tail, then we're going to do a bunch of stuff. So we're going to figure out if the ID that we have in pending is equal to this ID, which means we need to grab the this stuff here. I'm just going to copy it for right now. I don't know if I do need to enqueue it, don't I? Which means I would need to like grab it down here. We're doing this multiple times. So it's a little bit of duplicative work here. This might be better to break out into a different function. I believe it's loop stuff, if true break. This should also work because it will break as soon as this true. So like, I think loop and while are essentially the same, except this has a condition and loop is just while true. Okay, so self-depending. Self.tail, so now this is gonna be the index. So grab the one out of the index here. then wait a second, I need to do this in the if. Because I need to check it, don't I? It's not going to be quite as simple as just like setting this equal to it. I need to actually check to see the contents of this. So this is going to be a little bit more fun, as it were. So we want to do if let. Let's see. Let the ID. So let ID equals if let sum. This is going to be the ID equals, this is going to be the self dot pending position index dot ID. If this happens, then I want to return the ID. That gives me this sound here. And semicolon that. Right, else. If something else happens, I want to continue. I just want to continue. Now we have this ID. We're gonna need to set the volume, but let's wait off for a second. Now we can check, okay, so if the ID is equal to, well, this is a problem. I now have two IDs here. So let's do pending ID. Okay, so if ID is equal to pending ID, then we want to set the volume of that one to the highest one. So that's going to be this index, because we're still in this while loop here. So we're going to do self.pending of position index dot volume equals sum, and then the volume. Now, what are you saying? There is no binary operation equal because partial equal might be missing for sound. So let's go ahead and derive for sound partial equal. And it should be able to help us tell if like it's matching that. Yeah, okay, so that handles that. And this will break the index. So now we're setting the we're setting this properly. We want to, at the end of this loop, increment index properly, which is this right here. So index is going to be equals to index plus 1 modulus max audio pending. And then that will make this while loop work. So not the best one. This might be better as like a some kind of function that we call just to not clutter up play sound. We use the larger of the two volumes, and then all of the rest of this code, including this custom error here. So let's say we have this like max sound here. If I want to test this, I put in two play sounds of the same sound. I did one of, let's just say like 0.5 and one at max volume. When I call update, I should not get two sounds. I should really get 0.5 and probably an error or nothing at all, I guess. So that's a cargo run. Here we go. Play swoop sounds in channel 4 with volume 1. So it changed this to volume 1. So it found that properly. This happened again. Are we not DQing properly? So when I run update, we increase the head. So it's +1. And then if we're equals to this, we don't play the sound. And tail is incrementing properly. I wonder if I have like an off by 1 error somewhere. I probably do. Oh, I don't know off the top of my head where. And oh, that's all the examples that we have here. So we're good to go with this code, except for that weird bug where if I play update, I don't want this sound to be actually added in to this code. So in play sound, while we need to return. It did add this in, didn't it? Okay, so while index. So if this happens. If we find this, we also want to just straight up return like that. This will work. So if I play it, only one sound gets played, even though I enqueued 2 of them up. But it plays at the maximum volume that I wanted. So one was added in at half volume and one was added in at full volume. So what did we do here? Well, first of all, we created our own custom types, or specifically the custom error. And this allows us to sort of like mix and match our errors together. This is also super helpful if you have like another library that has its own errors. Create a custom error enum and then throw their errors in here, or at least like create your own versions of the errors. And that way you can convert over to it. It makes it so that you can control the errors a little bit better instead of constantly trying to guess like, okay, what error is coming in? I don't know what error is coming in. This allows you to wrap over it. If we look at our main function, the first thing we do is we initialize new audio. So what is that doing? Audio is simply a head and a tail and pending. All that means to us is that we have an array of these play messages, and we're saying that we're going to have 16 of them. And play message looks like this. It just has an ID and a volume. I'm making them have options for them, so that way we can initialize it with nones. I could say like, hey, you're all like, actually give it something, but that doesn't really make sense from like reading code point of view. However, in doing that, now when we play the sound, which is, it's not playing the sound right then, it's something requesting to the audio system that we do play the sound soon. We hand it the ID and a volume, and we're going to add that in here. So self.pending, we figure out where the tail is, and then we can set the ID to like, some ID, some volume. The problem here is that if we play 2 sounds of the same sound, we won't want to play both of them. Instead, we want to just set the volume to be whichever one is highest, and then exit out. This stops that problem. Have you ever played a game where like you do something and it like stops the sound and restarts it, so you can like create a little bit of like a weird sounding thing by just doing it over and over again? This prevents that. There's only one sound that happens at a time. And then we have our up, we play the sound that adds the sound into our queue, and then update is going to read from the queue here. First of all, it's going to check to say, do we even have any sounds to play? If not, okay, just don't do anything. If we do have a sound, extract the ID, extract the volume. Otherwise, return an error because clearly the sound is not found. And then finally, just go ahead, grab the resource, grab the channel information, and then call our start sound, which theoretically would do stuff. Right now, it's just, printing a line out. And then increment the head. So the tail and head are incrementing using this funky little mathematical algorithm we came up with. That all that's doing is saying, hey, if we're at the end of the array and we want to +1 index to it, just wrap around to the beginning. We could do a little bit fancier math and just say like, hey, if we're greater than the length of this, then go ahead and, set it to 0. This just does the math for us. So modulus, super nice. And then that's it for this entire pattern. This is basically an asynchronous queue system for handling events. It's also events that are directly attached to audio. If we wanted a queue system for like the player or anything else, we could implement this exact same thing in each struct that needs it. And that's it. So, Chantilly, good morning. We ended a few minutes early. I'm gonna go ahead and put a marker down